Okay, so mm, in today's lecture, we will discuss about some more terms used in one-dimensional motion, like linear motion, and those terms are the speed, average velocity, and speed, instantaneous, velocity and speed, and then average acceleration and instantaneous acceleration. So first we have to start from that the terms velocity. So in the last lecture we have discussed about the variation of position with time. So if this is a plot between time and position it is represented by x. Let's say we are talking about a one-dimensional motion, and one-dimensionally this x coordinate is taken. So this is a graph between x and t. If we have this type of line which is parallel to this time axis, then the motion means that object is at rest, because position is unchanged with time. And if this is another plot where this is the time and this is x, and we have this type of linear line which is starting from 0, and here as time increasing and simultaneously the position of that object is increasing, so that object is in motion. And also we have this type of plot also. This is 0 and t, and this is x, where this is the curve again here that with time position is changed. So when with time when the position of a body is changed, then that is known as the object is in motion, and where we have to define this average velocity and this speed. So if we take 2 points here, so at time this is t1, the position is x1, and after time t2, if the position is x2. So in the measurement we are measuring the position with time, then this gap, this difference is represented by this is from this point, and this is known as x2 minus x1, and this difference, this is represented as t2 minus t1. This is t2 and this is t1, so this difference will be t2 minus t1, and this is x2 minus x1. And the ratio of this, it is the ratio of x2 minus x1 by t2 minus t1. This is constant here in this case, and this is represented by v, and known as average velocity. The same thing is also true for this curve, and but in spite of this type of line, we have curve like this. Then we take one tangential line passing from this particular point, and then we can take 2 points here to here, and let's say this is x1, and this point is x2, and this is time t1, and this is time t2. Then this is t2 minus t1, and this will be x2 minus x1. So the ratio of this x2 minus x1, and this will be a constant, but this is known as the average velocity. So the average velocity, is the change in position with time. So per unit time, if there is a change in the position, then that the ratio of that change in position and time, this is known as velocity. And the unit of this velocity, obviously that the unit of velocity is this is in meter and this is time, so this will be in second. So also one should write the dimension, and the dimension of this average velocity, this is the length. So there is no mass term, so there will be m, and this is L and T inverse. So this is the dimension of this velocity. So the simple definition of average velocity is here, and this is just a change in the position with time. So as far as that average speed is concerned, this is the vector quantity. When we take this as a displacement, we'll talk this as a displacement, then that will be the velocity. And when we talk this as a distance, which one is the scalar quantity, then the ratio of that distance change with time, that is known as the speed. So speed is a scalar quantity and velocity is a vector quantity. So generally, if we talk about that velocity, then we have to give the direction also. So in our general bike or that vehicle, we have a speedometer, because the direction of that particular bike it changes frequently. So only that the speed is given, because the direction is not mentioned there. But when we give that the velocity that particular bike that is moving with 50 km/h with particular direction, then that is known as the velocity. So that is speedometer, not velocity meter, which is available in our vehicles. So now, so this x2 minus x1 and t2 minus t1, this is given a new representation like this. So this let us represent this let this x2 minus x1, it is represented by delta x. So a small change if, and then t2 minus t1, this is represented by delta t. Then this average velocity, v average, so I should write v average here. So average velocity, this is x2 minus x1 by t2 minus t1, and one can also write this delta x by delta t. So this delta x by delta t, this is change in position and this is change in time. So this delta term is used to show the variation in general physics and mathematics. So if this change is small, this change is small, then we have another term so if here, if this delta t tends to 0, means this time, change in time is taken infinitesimal, very small, then this delta t can be taken as tends to 0, and this, so one can represent this as if this delta t tends to 0, then this implies the limit of delta t tends to 0, delta x by delta t. So here this delta t tends to 0, and this is taken as equal to dx by dt, and this is from the definition of derivatives, differential. So from the definition of differential, one can write this delta x by delta t. When this delta t, the denominator, this tends to 0, then this can be written as equal to dx by dt, means the differentiation of x with respect to this time delta t. And now this is represented by another term, that is v instantaneous, which is known as instantaneous velocity. So that instantaneous velocity is actually the velocity of any object, any body at particular time, instantaneous at a particular time. So this is the velocity of an object at a particular instant of time. So this is the velocity at a particular instant of time. So that dimension and unit will be same. Main difference is this is the averaging. Average velocity is just the change in displacement upon change in time, and then this we take this is delta t tends to 0. When we take this one specific time, then for example, if want to calculate that particular velocity somewhere here, a particular time, then that velocity is known as instantaneous velocity. So this instantaneous velocity, this is equal to dx by dt. So we have two formula for the velocity. One, the average velocity is this, and then v instantaneous velocity, v instantaneous velocity, that v instantaneous, that is equal to dx by dt. So we have this v average is this. So dimension in units are same. Now we have what's about that is speed. So at particular instant of time when we measure that speed, that is known as the instantaneous speed, and obviously that is the scalar quantity, and that velocity is the vector quantity. Now the second term. So if we have given some this position as a function of time, then we can differentiate it, and we can get that the instantaneous velocity at an instant of time. And also let's have some simple example like this. If this x is a function of time, so x is equal to 3t square minus 2t plus 1. This is a simple example. There is the function of time. So where x is in meter and the t is in time. If you want to calculate the average velocity in between, the average velocity, this can be calculated in between two times. Let's say that t1 is equal to 2 seconds and t2 that is equal to 5 seconds. Then just by putting this t1 as 2 seconds here and t2 as a 5 seconds here, one can calculate the x1 and here this x2. You can calculate this x1 and x2 here. So by putting this to t is equal to 2 here, we will get x1, and by putting this t2 is equal to 5 here, we will get x2, and then by using this formula we can calculate average velocity. Whereas in order to calculate that instantaneous velocity, we have to differentiate this. So after differentiating this, this term will be omitted because this is the constant one. So this will be 3 multiplied by 2, 6t minus 2. So for a particular time, t is equal to 4 seconds, t is equal to 7 seconds, we can calculate that velocity, and that will be the instantaneous velocity. Average acceleration and instantaneous acceleration. So next term is that this is very important terms in dimensional motion, that is the average acceleration and the instantaneous acceleration. So in place of that position and the time plot, let's have same plots. If this is the x-axis is still the time and the y-axis is the velocity, and this is 0. If you are getting this line which is parallel to t, means time is increasing but the velocity is not increasing, it's a constant. So body moving with constant velocity. So there is no change in its velocity, it's moving with a constant velocity. So 30 km per hour forever. So that is the fixed velocity. This is represented by this plot. And we have another plot that is 0 and t, and this is velocity, and this is that line. So here initially that body was at rest, and now which starts moving, and its velocity is increasing with a particular rate. So this is body moving varying velocity. And the third one, again, here this variation is constant, and this t, and this is v, and we have this plot. And this is also the same, that body is moving with varying velocity, but the variation, in this case, that variation is constant forever, but here that variation is not constant, it's also varying at different points. So now, so here that velocity constant. Now here we will take 2 points, so these are 2 points, and let's say this is a time t1 and this is time t2, and this gap, this is t2 minus t1, and here let's say that velocity is v1, and here that velocity is v2, and this difference is v2 minus v1. And similarly, we take one point somewhere here and take one tangent line passing through this particular point. So this is that tangent line passing through this point, and again we are taking 2 points here, and this is t1 and this is t2. So this difference, this is t2 minus t1, and here let's say this is v2 and this point is v1. So this difference is v2 minus v1. And the ratio of this, the ratio that v2 minus v1 by t2 minus t1, this is a constant, and this is represented by a, and I am representing this as the average. So this is a average, which is average acceleration. So this is the average acceleration. So here also that v2 minus v1 by t2 minus t1, and here this is v2 by v1 minus t2 by t1. So if this is one straight line, so that variation is constant forever, and but here this variation is little bit change point to point. So at a particular point we take one tangential line, and we can get that v2 minus v1, and the ratio with this v2 minus v1 by t2 minus t1 is the average acceleration. So therefore the average acceleration is actually change in velocity with time. So this is the change in velocity with time. So again we can write that the unit of acceleration this is velocity, and velocity is meter per second, and this is second. So this is meter per second square, and the dimension of acceleration, this is that velocity, and the velocity is m naught lt inverse, and this is another t, so this is t minus 2. So this is the unit and dimension of this acceleration. So average velocity, that average acceleration is defined as the ratio of the change in velocity with time. And now let's again use the same process to reduce this time period. So one can represent this. So let v2 minus v1, it is represented by delta v, and t2 minus t1, it is represented by delta t. Then average acceleration, it is defined as equal to v2 minus v1 by t2 minus t1, and this is equal to delta v by delta t. If this angle is theta, let's say if this angle is theta or this angle is theta, then this ratio can be also represented as equal to tan theta. This is also written as tan theta. So now if this delta t tends to 0, again we are taking this time interval as infinitesimal, very small value, then this delta t tends to 0, then this limit delta t tends to 0, this implies delta v by delta t can be written as equivalent to dv by dt. So this is from the definition of differentiation. So from the definition of differentiation, one can write this limit delta t tends to 0, del v by del t is equal to dv by dt. So this is known as instantaneous. So this is dv by dt. So instantaneous acceleration is represented by derivative of velocity with respect to time. So the instantaneous acceleration is the acceleration of any object at a particular instant of time. So at a particular instant of time, this that acceleration is known as that instantaneous acceleration, and it is represented by derivation of this v with respect to time. So if that velocity it is represented by the function of time, then we can just take the differentiation, and by putting the value of that particular time at which we want to calculate that acceleration, just put that time and we can calculate acceleration, that instantaneous acceleration. So this is the simple introduction, and obviously here that the unit and dimension of that instantaneous acceleration will be similar to same to that the unit and dimension of average velocity, average acceleration. So that acceleration may be positive, negative. If that acceleration is negative, then it is known as a retardation, and acceleration is a positive, then this is the acceleration. Positive acceleration means we are just gearing up, we are just increasing the velocity of that particular vehicle. If we talk about that vehicle and we are using that accelerator, so we are increasing the velocity, then the acceleration is positive. When we are using brake, then the acceleration is negative. So that this is the vector quantity. So obviously that will be either 0. 0 means that object is that vehicle or that object is moving with a constant velocity. There is no variation in its velocity. And if that it is positive, means we are speeding up that vehicle or that body, and if that acceleration is negative, means we are just using brake to stop that vehicle. So that that is speeding down, that the speed is tends to 0, means we are using brake, then that acceleration is negative. Anyway, so I think this today's lecture it's more than sufficient. So enjoy learning. Thank you all.